everyone, welcome to my channel. Today I am going to teach limits and derivatives, that is chapter number 13. So exercise 13.1, first question is evaluate limit x tends to 3 x plus 3. Where there is a x, you need to substitute 3 here. So 3 plus 3 is 6. Second question is limit x tends to pi x minus 22 upon 7. In place of x, I need to substitute pi. As you know that pi value is 22 by 7 minus 22 by 7. These both will get cancelled. So answer is 0. Third question is limit r tends to 1 pi r square. Where there is a r, you need to substitute 1 here. So 1 square is 1. Again the value will be pi itself. The fourth question is limit x tends to 4. 4x plus 3 divided by x minus 2. Where there is a x, I am going to substitute 4. 4 4s are 16 plus 3 is 19. 4 minus 2 is 2. Okay. Fifth question. Limit x tends to minus 1. X raised to 10 plus x raised to 5 plus 1 divided by x minus 1. Where there is a x, substitute minus 1. So minus 1 raised to 10 plus minus 1 raised to 5 plus 1 divided by minus 1 and a minus 1. So this is an even number. So minus 1 raised to even number is always a positive number. Minus 1 raised to odd number is a negative number. So plus 1 minus 1 get cancelled. What is remaining? Only 1. Minus 1 will become minus 2. So the final answer is 1 divided by minus 2. Sixth question. Limit x tends to 0, x plus 1 raised to 5 minus 1 divided by x. Fine. Now here what I have done is I have added and subtracted by 1. You can see here I have added and subtracted by 1. Again it will get the same thing. Now there is a formula. Limit x tends to a, x raised to n minus a raised to n divided by x minus a is equal to n into a raised to n minus 1. So this is in this form. So you can see here x raised to n minus a raised to n, that is 1 raised to 5 is 1 itself. So your n value will become 5 here, a value will become 1, n is again 5 minus 1. 5 minus 1 is 4. 1 raised to anything is 1 itself. So 5 ones are 5. Right? Seventh question. Limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. Here you need to factorize this numerator. You have already studied in the lower classes, right? After factorizing this, you will get 3x plus 5, x minus 2. Now x square minus 4 can be written as 2 square. Again a square minus b square formula. A plus b, a minus b. That is nothing but x plus 2, x minus 2. Numerator and denominator both get cancelled. Where there is a x, substitute 2 here. So 3 2s are 6 plus 5 is 11. Now here if you substitute 2, so 2 plus 2 is 4. So the final answer is 11 by 4. Let's move on to next sum. Now 8th question. Limit x tends to 3, x raised to 4 minus 81 divided by 2x square minus 5x minus 3. So the solution is limit x tends to 3, x raised to 4. 81 can be written as 3 raised to 4. This denominator should be factorized. So after factorization you will get 2x plus 1, x minus 3. Fine. Now this can be written as x square minus 3 square and x square plus 3 square. It means a plus b, a minus b formula. Fine. So we have applied a formula over here. Again we are going to apply a formula a square minus b square, that is a plus b, a minus b. This you have to write as it is because there is no such a formula for that. Denominator write as it is. Now numerator and denominator get cancelled. Where there is an x, put 3. So 3 plus 3 here, 3 square plus 3 square divided by 2 into 3 plus 1. 3 plus 3 is 6. 3 square plus 3 square, that is 9 plus 9 is 18 divided by 2 3s are 6 plus 1 is 7. 6 into 18 is 108 divided by 7. Ninth question now. Limit x tends to 0, ax plus b divided by cx plus 1. Where there is a x, directly substitute 0. A into 0, 0. So numerator you are remained with the b. c into 0, 0 plus 1. So in denominator 1. So the answer is b by 1. You can also write only b. So 10th question. Limit z tends to 1. In the numerator z raised to 1 by 3 minus 1. Denominator z raised to 1 upon 6 minus 1. So here what you have to do is numerator and denominator divide by z minus 1. Here and here. Fine. So this will form a formula. I have previously solved one of the question. So limit x tends to a, x raised to n minus a raised to n divided by x minus a. That is n into x a raised to n minus 1. So this will become, you can see here n value is 1 by 3, a value is 1, 1 by 3 minus 1 divided by, in the denominator n value is 1 by 6, 1 by 6 minus 1. Now 1 raised to anything is 1 itself, 1 raised to anything is 1 itself. So 1 by 3, this 3 goes in the denominator, 1 by 6, this 6 goes in the numerator. Again these are basics. So 6 divided by 3. So 3 ones are, 3 twos are. So final answer is 2. 11th question now. Limit x tends to 1, ax square plus bx plus c divided by cx square plus bx plus a. Where there is a x, substitute 1. So 1 square is 1. So you are remained with a. B into 1, b, c, and c, 1 square is again c itself. B into 1 is b plus a. So numerator and denominator both are same. If you cancel, you will get answer as a 1. So 12th one. So limit x tends to minus 2. Here 1 upon x plus 1 upon 2 divided by x plus 2. You need to take LCM for this. Okay. So limit x tends to minus 2. Take this 2, multiply here. 2 ones are 2. So I have written here 2. Plus x into 1 is x. If you multiply this, you will get 2x. Write this denominator part as it is. You can see 2 plus x and x plus 2. Both are same. So both are cancelled. Fine. You are remained with 1 divided by 2x. You can see here. Now substitute x value as a minus 2 here. So 2 2s are 4. Minus remains here. So the final answer is 1 divided by minus 4. Let's move on to the next sum. Thirteenth question. Limit x tends to 0 sin ax divided by bx. Now here what you have to do is I have divided and multiplied by a. Fine. I am going to rearrange now. In place of b, I am going to interchange this. So you can see here I have written all the terms same, but in place of b, a, and in place of a, b. You can tell I have interchanged. Fine. Now this whole term is a formula. Limit x tends to 0, sin x upon x is a 1. So this whole term will become 1 into a divided by b. So final answer is a upon b. 14th question. Limit x tends to 0, sin ax divided by sin bx. So limit x tends to 0, sin ax. Fine. Now like this I have multiplied and divided by ax upon ax. Fine. Now denominator also I have taken limit sin bx into bx upon bx. Same like in the previous sum. Fine. Now this whole term by this formula I have written 1 here. So what I will get here? Ax. In the denominator part, this whole term by this formula I have written 1 into bx. In the numerator x, in the denominator x, both will get cancelled. So 1 into a is a, 1 into b is b. So this is your final answer. Fine. 15th question. So limit x tends to pi, sin pi minus x divided by pi into pi minus x. So it is very difficult or a complicated sum to solve. So what I have done is in the easy method, take y is equal to pi minus x. Now when x tends to pi, so in place of x I have substituted pi. So pi minus pi is 0. So y is going to tend with the 0. So this I have written limit y tends to 0. Because of this, sin y, this whole term I have taken as a y. This term will become y. So here pi. So limit y tends to 0 sin y upon y. From this formula it is 1. So 1 divided by pi, because denominator there is a pi here. Fine. 16th sum. Limit x tends to 0, cos x divided by pi minus x. Here simply substitute x value as a 0. Cos 0 is 1. Here in place of x, 0. Pi minus 0 is pi. So the final answer is 1 divided by pi. So let's move on to the 17th question. 17th question. Limit x tends to 0, cos 2x minus 1 divided by cos x minus 1. Limit x tends to 0, cos 2x minus 1 is minus 2 sin square x divided by cos x minus 1 is minus 2 sin square x upon 2. These two are formulas from chapter number 3, trigonometric function. You go back to chapter number 3, you will come to know these formulas. Fine. Now this minus 2 and minus 2 get cancelled. So you remain with the sin square. But according to the formula, sin square x divided by x square into x square. It means numerator and denominator I need to divide by x square. Fine. Here in the denominator part, here it is x upon 2. So what I have done is x upon 2 square divided by x upon 2 square. So here you can see this whole term looks like a formula. So I have written this as a 1. So what is remaining here? Only x square. In the denominator part, this whole term is a 1. Okay. Now what is remaining here? X upon 2 whole square. So I have written x square. 2 square is nothing but a 4. X square get cancelled. This 4 goes to the numerator. So the final answer is 4. I hope you are understanding. 18th sum. Limit x tends to 0, ax plus x cos x divided by b sin x. What I have done is I have separated these two. Limit x tends to 0, ax you can see here divided by b sin x plus x cos x. Again I have written in the denominator b sin x. So here limit x tends to 0. This x which was there in the numerator part I have taken here in the denominator at the last. Okay. Now plus again I have applied limit for this cos x. This x I have taken at the last here in the denominator part below the sin x. Both will be remain same. Now again limit x tends to 0. Sin x upon x is a 1 from this formula. So what is remaining here? A upon b plus limit x tends to 0. Sin x upon x is a 1. So what is remaining here? Cos. So in place of x I have substituted 0 here divided by b. As you know that from here formula cos 0 is 1. So 1 divided by b, and here it is a by b. If I take LCM, when denominators are same, you need to add the numerators. That is a plus 1 divided by b. Fine. 19th question. Limit x tends to 0, x secant x. So limit x tends to 0, x secant from 10th standard. It is a formula 1 divided by cos x. So I will substitute x value as a 0 in the numerator and here in the denominator cos 0. So from the formula cos 0 is 1. 0 divided by 1 is 0. So let's go to the 20th sum. Now 20th question. Limit x tends to 0, sin ax plus bx divided by ax plus sin bx. So I am going to divide all this by x. So limit x tends to 0, sin ax upon x plus bx upon x, ax upon x plus sin bx upon x. Fine. Now for this there is the a coefficient. So I am going to divide and multiply and divide by a. Plus x cancel, only b is remaining. X cancel, only a is remaining. Here the coefficient of the x is b. So I have multiplied and divided by b. As you know that this whole term is a 1. So what is remaining? Only a is remaining here plus b. Here a is remaining in the denominator. This whole term is 1. In the previous sums I have written the formula. So b is remaining. So a plus b both will get cancelled. So the final answer is 1 here. 21 question. Limit x tends to 0, cos x minus cot x. As you know that cos x is cosec x. Cosec x is 1 upon sine minus cos upon sine. So if I take LCM, 1 minus cos and denominators are same, so I have written only sine. Now I am going to divide this by x. You can see in the numerator also I have divided by x, in the denominator also I have divided by x. There is a formula, limit x tends to 0, 1 minus cos x upon x is a 1, and limit x tends to 0, sin x upon x is also 1. Okay, there is a formula for this. So 22nd question, limit x tends to pi by 2, tan 2x divided by x minus pi by 2. Here I have taken y is equal to x minus pi by 2. Fine. When x is pi by 2, then in place of x, if I substitute pi by 2, pi by 2 cancels, so y will become 0. So limit x, y tends to 0 here, tan 2, in place of x, I have written y plus pi by 2, because this minus will come on the left hand side, it will become plus. Now denominator part whole is a y. Now these two multiply for both, 2y plus this two get cancelled, only pi. Fine. Now as you know that tan pi plus theta, that is third quadrant, so it will become only 2 pi. I repeat, tan 2y plus pi is a third quadrant, so it will become only tan 2y divided by y. The coefficient of the y is 2, so I have multiplied and divided by the same number. So this whole term is by formula. Fine. So you will get 1, and 1 into 2 is a 2. So 23rd question, find limit x tends to 0 f of x and find limit x tends to 1 f of x. So given question is f of x is equal to 2x plus 3, x is less than or equal to 0, 3 into x plus 1, x is greater than 0. So LHL, left hand limit. Fine. Limit x tends to 0 raised to minus 1, because it is less than, remember that. Okay, so I have written 2x plus 3. Where there is a x, I will substitute 0. 2 into 0 is 0 plus 3. So the answer is 3. Now since there is an equal to sign here, so I have taken f of 0. So I have written this, 2 into 0 plus 3. 2 into 0 is 0. 0 plus 3 is again 3. Now RHL, right hand limit. Limit x tends to 0 plus, because it is on the right hand side. So here they have given 3 into x plus 1. Where there is a x, put 0. 0 plus 1 is 1. 3 ones are 3. It means you can see here LHL is equal to RHL and is equal to f of 0. Okay. So now this is over. Now limit x tends to 1. I have taken this. Why? Because when x tends to 1, it is greater than 0. You cannot take this one. So 3 into x plus 1. 3 into 1 plus 1 is 2. 3 2s are 6. This completes your answer. 24th question. Find limit x tends to 1 f of x. They have given f of x is equal to x square minus 1. X is less than or equal to 1. Minus x square minus 1. X is greater than 1. Now LHL, left hand limit. Limit x tends to 1 minus, because it is on the left hand side. So x square minus 1. 1 square minus 1. 1 minus 1 is 0. F of 1. So I have taken this one, because there is a equal to sign here. So 1 square minus 1. Again it is 0. Right hand limit. RHL. Limit x tends to 1 plus, because it is on the right hand side. So I have taken this one, minus x square minus 1. So in place of x, I have written 1. Minus 1 is minus 2. You can see LHL is 0, RHL is a minus 2. They both are not equal. When they are not equal, you need to write limit x tends to 1, f of x does not exist. Fine. Now 25th question. Evaluate limit x tends to 0 f of x. They have given f of x is equal to modulus of x divided by x. X is not equal to 0, and if it is 0, then x is equal to 0. So not equal to 0 means it might be either less than or greater than. So since this is a modulus, I have written once minus and once plus. So I have taken minus x upon x plus x upon x. I repeat, when it is not equal to 0, either it might be less than or greater than 0. Fine. X get cancelled, so minus 1. x get cancelled, so it is plus 1. So minus 1 when it is less than 0, plus 1 when it is greater than 0, and 0 as it is I have kept. Now left hand limit, as you know that x tends to 0 minus. Why? Because it is left hand limit from here. Okay. Now what is here? Minus 1. There is no x here to substitute, so you have to write that same minus 1 here. Right hand limit, limit x tends to 0 plus, because it is on the right hand side. So here it is plus 1. So you need to write here plus 1. Okay. So LHL is minus 1, RHL is a plus 1. So LHL is not equal to RHL. So limit x tends to 0, f of x does not exist. 26th question. Find limit x tends to 5, f of x. F of x, they have given modulus of x minus 5. I have told you, whenever there is a modulus, okay, once you need to take minus, once you need to take plus. When you take minus, then it is less than. When you take plus, then it is greater than. So left hand limit, LHL, limit x tends to 5 minus, so minus x minus 5. Where there is a x, put 5. So 5 minus 5, 0. RHL, limit x tends to 5 plus, so I have taken plus x minus 5. Where there is a x, substitute 5. 5 minus 5 is 0. So LHL and RHL both are equal. So here I have written LHL as a left hand limit. You need to take minus. Here you can see. RHL means right hand limit, that is plus. You can see here. Let's move on to the next question. Now 27th question, f of x is equal to a plus bx, x is less than 1, 4 when x is equal to 1, and b minus ax when x is greater than 1. Find limit x tends to 1, f of x. So left hand limit, that is LHL, limit x tends to 1 minus a plus bx. Where there is a x, I have substituted 1. Fine. RHL, so limit x tends to 1 plus b minus ax from here. Where there is a x, I have substituted 1. Okay. Now f of 1 is 4, because x is equal to 1, it is 4. Now here I have taken LHL is equal to f of 1. LHL is a plus 1b from here is equal to 4 from here. RHL is b minus 1a is equal to f of 1 is 4. So what I have done is this minus 1a will go to the right hand side, so it will become plus, so 4 plus a. This b value I am substituting here, a plus in place of b, 4 plus a is equal to 4. This 4 get cancelled, a plus a is 2a, this is equal to 0. So a is equal to 0 upon 2 is nothing but 0. So a value I am going to substitute here, b is equal to 4 plus 0. So answer is 4. So 28th question is, let a1, a2 so on up to an be the fixed real numbers, and f of x is x minus a1, x minus a2 so on up to x minus an, that is nth term. What is the limit x tends to a of x? So limit x tends to a, f of x is equal to, I have written this question here. Where there is a x, I have substituted a. So a minus a1, a minus a2, a minus a3 so on up to a minus an. So this completes the 28th question. 30th question is, evaluate limit x tends to 1 f of x. The question is, limit x tends to 1 f of x minus 2 divided by x square minus 1 is equal to pi. So this denominator part I am multiplying on the right hand side, that is with the pi. And this minus 2 when goes to the right hand side, it will become plus 2. So 2 plus pi into x square minus 1. Fine. Now limit x tends to 1 f of x. Here also on the right hand side I have applied limit x tends to 1, 2 plus pi x square minus 1. Where there is a x, substitute 1. So 1 square is nothing but 1. 1 minus 1 is 0. 0 into pi is 0. So 2 plus 0 is 2. This completes your entire exercise. I hope you understood very well, and thanks for watching. Keep watching the videos for more chapters.